Okay, welcome back. This is part 2 of the related rates lecture. In part 1, the first related rates video, we just did a really basic example. The cube was being inflated and the volume of the cube was increasing and the side of the cube, S, was also increasing. And we were given the rate of change of the volume, and we were asked for the rate of change of the side at a particular instant, and we could do that by finding an equation relating the two rates and then plugging in. But to get the equation that related the rates, we had to have an equation that related the quantities V and S, and then differentiate that equation. So, and then I showed you the steps. There's 7 steps. Most of your homework problems are going to be more complicated than that one, the cube one. They're going to be more like this problem that we're going to do in this video. So we're going to need all 7 steps, and you're going to need this handout. And I really want to emphasize to use this handout, use these steps. Start with step 1, end with step 7, and don't do them out of order. Because you will most likely make a mistake. So after you do several of these problems following my steps, you'll begin to understand why certain things have to be done in a certain order, and you won't need the handout anymore. You'll just know how to do the problems. But please, please, please try to use the handout, follow the steps when you're starting out on this homework assignment. So in this example, I'm going to use the steps and explain to you how to use them. So step 1 says read/understand the problem. So the problem says a water tank has the shape of an inverted circular cone with base radius 2 meters and height 4 meters. So inverted circular cone, you may not know what that means, but it's a cone, and because it's a water tank, it has to hold some liquid. It probably has to have the pointed part at the bottom and the circle part, the wide part at the top, because it is to hold liquid. The height is 4 meters, and the radius of the base, which is at the top of the cone, is 2 meters. So those two things are fixed. They're not changing. So then it says if the water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. So there's a lot going on in that sentence. There's a lot that's changing. So the water is being pumped into the tank. So imagine the water that's inside the tank. It's starting at T equals 0. It's starting with no volume inside the tank. There's nothing in the tank yet. And as water enters the tank, it's filling up the tank. So the water is taking on the shape of a cone. So that is also a cone. So there are 2 cones. There's the tank, and then there's the water that's in the tank. That's also a cone. And the volume of the water that's in the tank is increasing. In fact, it's increasing at a rate of 2 cubic meters per minute, the rate at which it's entering the tank. And we can picture that. We can picture the water filling up the tank. The water level is the height of that cone, the water cone, or the conical shaped water. That height is increasing. The height of the tank is not increasing. That stays constant at 4. But the height of the water inside the tank is increasing. And we don't know if it's increasing at a constant rate. But we're asked to find the rate at which it's rising at a particular instant, at a particular moment, at the moment when the water is 3 meters deep. So when the height is exactly 3 meters. The other thing that's changing is the radius of the surface of the water. So the water inside the tank is taking on the shape of a cone, a smaller cone than the tank, and so the top of the surface of the water is circular. And as the water level increases, the top of that conical shaped water is getting wider. So the radius of the surface of the water is also increasing as it fills up the tank. Okay, so we've read and I think we understand the problem. And so now let's move on to step 2. Draw a picture if possible. So most of your related rates problems, you're going to be able to draw a picture. So this one, I just draw a cone with a pointed part at the bottom, and I'll label the dimensions. The height is 4, and the radius of the base at the top is 2. That's it. I haven't got any variables yet, so I haven't labeled anything with a variable yet. So let's go to step 3. Step 3, it says assign variables to quantities that are changing, and then label the drawing. So, as I said, the quantities that are changing are the volume of the water, the height or water level, and the radius of the surface of the water. So let's give those things variables. So let's let V be the volume of the water at time t. Remember, it's changing, it's not constant. And then let's use H for the height of the water at time t. And let's use R for the radius of the surface of the water at time t. All right, so let's label. So there's the water, the green cone inside the conical tank. That's the water. And notice I labeled the height H. I did not label it 3 because the water level is not constant. It's not always 3. It's changing, so I had to call it a variable. And the radius is also changing, so that gets a variable. Okay, step 4, state the given rates and the desired rates in terms of derivatives of the changing quantities. So our changing quantities are V, H, and T. It's not T, R. So what are we given? So let's look back at the problem. I'm going to write down given and find. So what I'm given is that the water is being pumped into the tank at a rate of 2 cubic meters per minute. So that's what we're given, and that is the derivative of the volume with respect to time. So that's dV dt. You have to write it down as a derivative. Students usually just write down 2 cubic meters per minute and as they're given. But then later they don't know what that means. What is 2 cubic meters per minute? So you have to write a derivative is equal to 2 cubic meters per minute. So there it is, dV dt equals 2 cubic meters per minute. And then what are we asked to find? We're asked for the rate at which the water level is rising when the water is 3 meters deep. So that is a derivative. It's the derivative of the height, h. So it's dh dt when h equals 3 meters. So that's step 4. We write down what we're given and what we're asked to find, and those have to be derivatives. Okay, step 5 says, now we have to write an equation that relates the quantities that are changing, not the derivatives, but the quantities. So the quantities are what? So we're writing down an equation relating the V and the H. So we look at step 4, we look at the derivatives that we need or that we're given and are asked to find. We're given a dV dt and asked to find a dH dt, so the next thing we need is an equation relating V and H. So we're looking for an equation relating the volume to the height. The volume of a cone and the height of a cone. Well, the easiest one to write down is the formula for the volume of a cone. The formula is V equals 1/3 pi r squared h. So that is a relation. It's an equation. It's relating V and H. It also has an R in it. So what we need to do is get an equation that just has V and H and no R. So we're going to try to get rid of the R somehow. Well, if we look at our drawing as a sort of two-dimensional thing, we can see there's two triangles, right triangles. There's the small one, the small right triangle, which has legs R and H, and then the larger right triangle, whose legs are length 2 and 4. And these have to be similar. They're similar triangles because the angles are all equal. So because they're similar triangles, we can write down a proportion. R over H has to be equal to 2 over 4. And then if we solve that equation for R, we get R equals 1/2 H. And now we can replace the R in that equation for the volume. We can replace R with 1/2 H. So let's do that. So now we can write down V equals 1/3 pi times 1/2 H squared times H. So we replaced the R squared with 1/2 H squared. All right. So now let's simplify that. So if I simplify it, I get V equals pi over 12 H cubed. Great. So now we have the equation that we were looking for in step 5. So step 6 says differentiate both sides. So on the left, the derivative is just dv dt. On the right, I differentiate h cubed and I get 3h squared times dh dt. And that's the chain rule. Okay, so now we're looking for dh dt, so let's solve this equation for dh dt in terms of everything else and simplify. So dh dt is 4 over pi h squared times dv dt. Okay, we're ready for step 7, the last step. Plug in and solve for the desired rate. So what are we plugging in? Well, we can plug in for dv dt and we can plug in for h because we're looking for dh dt when h is 3 meters, and we know that dv dt is 2 cubic meters per minute. So plugging those two things in, I get dh dt evaluated at h equals 3 is 4 over pi 3 squared times 2. And we can answer the question. The water level is rising at a rate of 8 over 9 pi, which is approximately 0.28 meters per minute. And that is our first real related rates problem.